So if you'd like to, please select your language that you'd like to listen to, either Spanish or English. That's going to be a symbol in the More button or in the Interpretation button at the bottom of the screen. And so we do have a Spanish-speaking presenter today, so anyone who is listening in English, please also select the English interpretation so that you can listen seamlessly when we switch speakers. Welcome, welcome. And we're just going to wait one more minute. So nice to see so many people joining from all over Chile, Moscow, Idaho, New York City. Okay, I think we'll start in just one more minute. All right, so for anyone just joining, if you need translation, and there is a Spanish speaker today, so anyone planning on listening in English, please also select the English channel in the interpretation button, and then anyone listening in Spanish, select Spanish, of course. So welcome to our new webinar series. We're the member connectivity subgroup of the Western Hemisphere Shorebird Group. And today we have a panel on foraging ecology of shorebirds, which we're super excited about because we have some really amazing speakers with really diverse expertise in foraging ecology studies. So just one last reminder about interpretation. We do have Spanish presenting speaker and English presenting speakers today. So please select Spanish or English by going to the bottom of the screen and pressing the interpretation button. And so with that, I will start introducing our speakers. We are going to first hear from one speaker who is joining us all the way from China, and it is very late over there, so he is only going to have time to take a couple questions after his talk. And then the following three speakers will be staying with us to have a group discussion on foraging ecology and answer questions in more of a panel format at the end. So with that, let's start with our very first speaker. I have the honor of presenting Dr. Hebo Peng, who's from Bird Eyes and the Guangdong University of Technology. So Hebo, if you'd like to start, thank you so much.
Okay, can you see the screen? Okay. Thank you. Thank you so much, and thank you for your invitation for this, for me to give this talk to all of the people, and it's my great honor to share this kind of my research to all of you. Today, my talk is about the blazing in this case, China's entitled mollusks marine culture helps to sustain the endangered shorebird flyway. So that's a quite long, sorry, it's a quite long title, but because I have worked with this for many years and then have some result to share with you. And I will first of all, I will start with breaking news. In 2018, a breaking news story sent shockwaves through the conservation list, working along the EF Flyway, and it was about a serious food crisis for the shorebirds at the Yalujiang wetland on China's coast. And why why the yellow giant is important, because it supports more than 300,000 shorebirds in the spring, and including 80,000 of green knot and 70,000 of buttergallowid. And what happened in Yalujiang? Because there are lots of shorebirds, the reason why the shorebirds stay there, because of they have abundance of food, and in 2013 the food declined 90% in this year and never recover until now. So still have very low food density now. And I was a master in that time, and I just think the food decline in Yalujiang, the most important site, and what happened in other suburb site. So I try to check what happened in other stop site along our flyway, and I find only 2 sites have the long-term study of the shorebird food, and that's all in the Yellow Sea, and one is Nambu and one is Yalujiang. But in such a big area, only 2 places we have data about about the food of the shorebird. So that's why we know nothing about we know few things about what happened for the shorebirds. And what's the situation for the shorebirds in this flyway is we found the shorebirds number declined so much, the shorebirds survival declined so much, and the people think the reason is mainly about the reclamation about the intertidal mudflight. But when I checked the data about the reclamation, I found the reclamation stopped in 2015 and a little bit increase in these years after that. And that means the reclamation is not the main threats now. And for me, I'm working on the foraging behavior, working on the food of the shorebirds. So I will think about what happened about the food, because only 2 sites we have data. So I try to do it by myself along the whole coast to see the food situation for the shorebirds in last 12 years. So what I did is just sample the macrobenthos on the mudflight, and we walked through from the south to the north every year for more than 40 sites every time. And now I'm still in the field work now. So, and we just sampled lots of locations each site, just to cover all the foraging area of the shorebirds in each site. So we have more than 2,000 sampling points for each year. And we also see lots of human activities, especially the aquaculture, the marine culture for the mollusks along China's coast. And you see here, they reseed the baby shellfish, and then when the shellfish grow up, they will harvest them and for sale for food. And we've also found lots of shorebirds. They are feeding on the same place with the aquaculture, with the marine culture. So that's very interesting for me. And I just think this is interesting. I will check what happened. So what we found, the first thing is because of high density of the marine culture along the intertidal mudflight on the intertidal mudflight. So they will of course change the biodiversity of the mollusks and the macrobenthos. And we found the farmed shellfishes account for more than 90% of the total mollusks. That makes sense because, the fishermen, they have to improve the products, so that's for sale. Sorry. And we also found lots of shorebirds, they are feeding on the mollusks. With some species, the mollusks account for more than 19% of the food. So that means mollusks are very important food for lots of shorebird species, especially for the species with very high numbers. And after this background of the information, we try to find the the relationship with the shorebirds and the mollusks. And we found along the whole coast where the high density of the farmed mollusks, where the shorebirds are higher. Here, there are very significant correlation with each other in the whole coast. And we also find with some long-term monitoring in some sites, we find when the farmed mollusks increase, the shorebirds will increase. And with the farmed mollusks decrease, the shorebirds will decrease. So they are linked closely with each other with the time. And that means the shorebirds distribution and the population dynamic are closely related to the distribution of and the abundance of this cultural mollusks. But for the conservationist, we always think the human activities maybe a not good thing. So we will think if without the agriculture, the things will be bad or not. So yeah, that's my next question. And it's lucky I have a chance to check this question. In one site in the south of China, we have a site. They cultured for 3 years, and then after that, the government they stopped the culture on the entire mudflat. So we have the data before the agricultural ban and after agricultural ban, and we find the shorebirds declined 50%, and the mollusks, the shellfishes, declined 70%. That's strange for me because I think when we remove the agriculture, when we remove the human activities, things will be better. But actually, they tend to be worse. So what happened? And we check the data and check the observation and find after the remove of the agriculture, the entire mudflat tend to be the common land, no people to manage the mudflat. So that means all the people can go to the mudflat every day to harvest the shellfishes, and also no people to reseed the small baby shellfishes into the mudflat. So that means all the things will be taken away by the people without managed. And you can see here they just harvest the every size of the shellfishes, and each species they will take off them when they see them. And you see here they just how to say, just disturb the the sediment every day and all the mudflat. So that's a higher disturbance for the than the stage of agriculture. So that means after the ban of the agriculture, the human disturbance not didn't decrease. Actually, they increase maybe 100 times than the agricultural stage. So our conclusion is manage the marine culture and not only provide the food for the shorebirds, but also helps maintain the entitled ecosystem by preventing overharvesting and regularly reseeding stocks. And yeah, that's all my talks. And I with this work, lots of volunteers and people help me a lot, and yeah, lots of fundings. And yeah, thank you for your attention. Yeah, that's all my talk.
Thank you so much.
Thank you.
If anyone has some questions, please feel free to drop them in the chat or unmute yourself and go ahead and ask them. Dr. Peng will have to be leaving because it is almost midnight over there and he has to go wake up at 5 in the morning to do more benthos sampling as they travel across the coast. Yes, Dan, please unmute yourself.
Hey, thanks, Tara. Thanks, Hebo. That was really fascinating. I wonder if you could give us an update. It sounds like you demonstrated pretty clearly this interesting dynamic, the tragedy of the commons. Are you going to be able to inform the government on ways to help manage the mudflats more effectively, given this interesting finding?
Um, yeah, that's a really a good question because yeah, we actually informed the government already, and lots of people help us to make some suggestion for the central government, but that's not a simple thing because they ban the agriculture not only for just the biodiversity, also for other things. So we need time to do it. But in my sense, I just think uh, how to say, because the shorebird is just a part of the uh, ecosystem. So I'm now working on more things, not only shorebirds, but also the all the macrobenthos and also fishes and all the other uh how to say the all the things on the mudflat to show the difference between agriculture and agricultural ban to see the agriculture actually increase all the biodiversity, not only shorebirds, not only macrobenthos. So and now I have the data, so I'm analysis that and then make the evidence is more stronger and then push the government to do better in the future because now they just think the evidence is not strong enough. So yeah.
Wow, great work. Thanks.
Thank you.
Um, just to make sure that we give time for other speakers, we'll just take one more question from Alexis Pristina. Do the farmers not mind that the shorebirds are feeding on their harvest? Thank you.
To the firms, not um actually they meant, but but in China the protection of the shorebirds actually is strict, so they will not harm for the shorebirds. But now they are now because of my study, they also understand actually the shorebirds is good for them because of the shorebirds, the agriculture they can be kept on in China, and then yeah, of course they want some kind of balance. Yeah, they can have some food for the shorebirds, also they have some good income. So yeah, they are not they are meant, but they're also happy. Yeah.
Awesome. Thank you so much.
Good. Thank
Thank
you.
you so much for sharing your work. And this was just a very quick snippet of Dr. Peng's work. So I've put a link in one of the papers that he was referencing here. But congratulations on such a huge feat that you do every year sampling the Chinese coast.
Okay. Thank you.
Um, and thank you again for joining us. So now we'll move on to our other speakers. And for these, I'll just remind everyone that if you could reserve your questions for the end of all three speakers, and then we'll have a group discussion if time allows. So thank you so much, Dr. Peng. And now we will move on to our next speaker, Gianco Angelozzi. Uh, Thank you so much. Take it away.
Okay,
Sorry, I'm
Sarah.
totally forgetting.
I'm gonna share my screen. Uh, Um, okay, I'm gonna flip to Spanish now. Um, can you can you see my slides now?
It's still loading on my end. Oh, okay, we can see them. And just a quick reminder, if you haven't already, if you are an English speaker, please join the English interpretation channel. Thank you.
Hello, everyone. Thank you so much for being here today. I'm going to show you some of the outcomes of my master's research, where we focused on the effects of environmental stressors on shorebird spray at stopover and non-breeding areas. Okay, so most shorebirds breed in the Arctic, and they use intertidal areas as stopovers. And for example, the shorelines in Canada are a critical area. On the Atlantic side of Canada are critical for migrating birds when they are traveling south. In these areas, birds are limited by the time they can stay, because the amount of foraging diminishes over time once they get to the non-breeding area, like the northeast part of Brazil. They are less restricted on food, but at both sites, we have a high abundance of prey. And that is extremely important to them because it provides them with the energy they need for migrating and for other physiological activities. In the intertidal areas, there is an invertebrate community that they use for foraging, for example, bivalves, polychaetes, and crustaceans. These groups vary in the movement ability that they have in the sediment, and that affects the amount of energy that the birds can get from them. So here we already have a couple of stressors that can have an influence in the availability and accessibility of this prey. In the case of stopover sites, we have post-tropical storms that we just recently started to study and to understand the impact that they have on invertebrates. And in the case of the tropics, in non-breeding areas, the effect of temperature in the sediment may have an influence in the availability of this prey. In the vertical profile of the vertical variation is very interesting because it may have an impact in morphology, which makes access to these resources a bit more difficult. So it is important to understand how these stressors can affect the birds. Additionally, the populations of shorebirds are not doing so well. Most of the species that use the Atlantic route are declining, as you can see on the graph. Here, I'm pointing out the species that we are studying in purple. So they're highlighted in purple, and we also know that climate change can have an impact, but we still don't know precisely how it can affect them. So this leads us to my research questions. Are prey communities disrupted by post-tropical storms at staging sites in Canada? And the second question is, does sediment temperature influence prey accessibility at non-breeding sites in Brazil? And so each question belongs to each time zone, each country. So we used this sampling in Canada in Petit Cap before and after Storm Fiona. This was in 2022 and in 2 different areas, and in Banco dos Cajuais in Brazil in 2024. In Brazil, we also measured the temperature in each of the layers of the sediment cores. And today I'm going to show you the outcomes of 3 different areas that we sampled. This vertical type of analysis of the sediment was interesting because it gave us a better idea on the availability for foraging for the birds depending on the type of beak that they have. For example, we have shorebirds that have very short beaks, and we have shorebirds that have very long beaks, so they have access to prey that is in the lower layers of the sediment. So the results that we had before and after Fiona, we saw that it did have certain effects in the area. In the graph, you can see that in the x-axis we have the sampling, and in y we have the average density of polychaetes. And what we found is that after the storm, the densities decreased in one of the sites, but they recovered. So there was a very short negative effect, and then the population recovered fairly easily. In the case of the area that is further inside, we saw the opposite pattern. We had an increase in the abundance of prey after the storm, and then the densities stabilized. So we have not only one effect on total abundance, but also in the vertical distribution of the prey. But that effect does not last very long over time. After 2 weeks, the numbers were back at the same. So immediately after the storm, the shorebirds did have lower availability of food in one of the sites. So now for the results of the effects on temperature for the vertical distribution of the prey, we can see here that the abundance for superficial layers and for the deepest layers of the sample. We have two different patterns between the polychaetes, which are at the top, and the bivalves, which are in the lower part. And in the polychaetes, we had a negative effect of the temperature in the most superficial layers of the sediment. So as the sediment heats up, we have a less availability for shorebirds that need to get their food from there, because in the deepest layers we did not have that effect. In the case of bivalves, we did have a negative effect in availability, and it was both at surface layers and bottom layers. So temperature does affect the availability of the prey, but it depends on the site, and it depends on the type of prey that we are working with, and also the high tidal amplitudes. So the results are pointing us into the role of stressors on the prey for shorebirds, not only in the breeding areas, but also the non-breeding areas. And these outcomes we can use to inform conservation decisions to manage climate change, to mitigate climate change. We think further research should examine the role of storms in the survival of shorebirds, as well as the effects of increased temperatures in the tropics, especially for prey that are not very well researched yet, and especially when we have climate change already here, basically. And I want to acknowledge everyone that was part of this and all the sponsors that made this research possible. And with that, that's all. And I'm ready for any question that you have.
Thank you so much, Gianco. And Gianco is a recent master's graduate from Mount Allison University, I forgot to mention before his talk, who has several years of experience working in both the coasts of Canada and northern Brazil and Venezuela. So thank you so much for sharing your expertise with us today. Again, these are just snapshots of all of the work that these speakers are doing. So please start thinking of your questions and putting them in the chat. And we're going to talk with Gianco again after our next speakers. So thank you, Gianco. And with that, we're going to pass to our next speaker, Lynn Brown, who's currently a PhD student at Trent University in Ontario, Canada. And I'll let her explain the rest. So take it away, Lynn.
Perfect. Can you see my screen okay?
Yes, beautiful.
Okay, awesome. Today I'll be sharing some of my PhD work on the diets of American oyster catchers, where we show the first case of diet specialization for this species. And this work has been carried out with the support from a number of funding groups, without which the work would not be possible, as well as help from the staff at Chincoteague National Wildlife Refuge and many of our partners, who it was a pleasure to work with. So I study American oyster catchers. These are birds that can breed on beaches along the Atlantic coast of the United States, and they provision their chicks. And what they're eating are bivalves, so those include oysters, mussels, and clams and razor clams at bayside mudflats, as well as marine invertebrates at oceanside shorelines, like the mole crabs pictured in the bottom right. And I work on 2 islands in the state of Virginia, Assawoman and Assateague Island. And to do this research, we make behavioral observations on foraging birds, where we can record what prey species they eat, how much, and how much they feed their chicks. And most of our birds are banded, so we also record that band combination. And this is complemented with their foraging movements from GPS trackers. So to do this, we first have to capture the birds to put on their GPS tags. These are very territorial birds. So if we place some decoys at their nest site and play their alarm call, which sounds like this, and bury our leg-looped carpets around their trap that have monofilament lines, they often get caught. So I have a video of that here. Oops. So the nest was originally in the tire, and we buried the traps around the tire after removing the eggs. And the pair starts doing their characteristic piping display. So they're running up to attack those intruders, in this case, the decoys. Both pair members are involved. They're bobbing their heads. They're walking with determination, and sometimes during this display, one of the pair members will get caught, and that's how we're able to ban them and put their GPS tags on. So you'll see the bird on the left. If you focus on that one, it trips, so that's when it would get caught. And when we have them in hand, we put on their PathTrack Nano GeoFix RF tags. These tags took a GPS fix every 15 minutes at a 10-meter spatial resolution, and we had 10 of them that were attached to birds for a full calendar year. And these were attached with leg loop harnesses. And we got the data using a remote base station and Bluetooth. These animations show the GPS tagged birds. So the left map shows the typical oyster catcher foraging strategy, where the birds are traveling usually around 2 kilometers away from their nests to feed at both the bayside mudflats and the ocean side. And this is what I'll call a generalist. But in comparison, if you look on the map on the right and really focus on the individual in the center in orange, this bird shows a much different strategy, staying very close to their nest, often within 300 to 500 meters, and primarily foraging on a single species, the mole crab. So this is the first case of diet specialization that's been described for American oyster catchers. And even though only one individual is pictured, here we identified 12 different specialists at our study islands. And the behavioral observations across 3 years and over 800 observations match the GPS tracking, and that's that the specialists on the right-hand side are primarily eating mole crabs more than 90% of the time compared to the generalists that eat a suite of different bivalve species on both the bayside and the ocean side. And we see a really specific spatial distribution for our specialists. They're shown as red dots. So you'll see they're only found on one of our 2 study islands. And that brings up the question of why we're seeing diet specialization. And partly it has to do with the prey. So if you focus on the left-hand map, where our specialists are shown in red, that map is really missing a giant purple blob like the map on the right, which is representing Atlantic ribbed mussels. There are some mixed rib mussels and oysters in the top of the left-hand map. But for a lot of the birds, they might need to travel over 3 kilometers away to reach those rib mussels, which is still within a reasonable foraging distance for this species. Sometimes we track the birds going 20 kilometers to forage, but it's still further than they'd like to travel, so they're instead staying close to their nests and only eating the mole crabs. Compared to the right-hand map, all of the pairs shown in black have close access within 280 meters to rib mussels, and they have a generalist diet. And the rib mussels are important because they're considered the most profitable prey a bird could eat, so the highest food weight divided by the handling time. But the second most profitable prey is the mole crab. And part of diet specialization has to do with the energetics of actually reaching the different prey habitats. So based on published data in the literature about the energetics, we are finding that the specialists would have to expend almost 40% more energy to reach the nearest mussel habitat compared to the generalists. So all of these factors led to diet specialization. And so what does this mean for the conservation of the American oyster catcher? Well, we need to help protect the mole crab populations and keep them healthy. So this means considering human disturbance activities as well as timing of other disturbance like beach renourishment that can all impact and potentially decrease mole crab populations. And so managing the beaches for mole crabs can also help a suite of other migratory shorebirds that also stop over and feed on these mole crabs. And I have my contact information here as well as a research website. Thank you very much.
Thank you so much, Lynn. And we can paste that link to your research website in the chat. Look for it. And with that, if you have any questions specifically for Lynn, please save your questions for the end or put them in the chat and we can address them at the end with the group. So thank you again so much for a great talk, Lynn. And we're going to move to our final presenter, Dr. Fernando Faria, who is a postdoc at Universidade Federal do Rio Grande do Sul in Brazil. So Fernando, take it away.
Hi guys, I'm not able to share my screen yet.
Okay, and if you need us to share the slides ourselves, we can also do that if
You should be able
Now I
to
think
now.
now I think I'm good. Thanks. Can you see my screen?
yes.
And okay, sorry. So hello guys, I'd like to start saying thank you again for this invitation and congrats for the initiative. It's a pleasure for me to talk about these shorebirds and trophic ecology, and this is a very nice initiative. So thank you and congrats again. I will start just briefly explaining a little bit about my study site. Most of you doesn't know. I know Kirsty, Tara, and Jason knew this site recently. So I'm based on the southern Brazil, in the southernmost state called Rio Grande do Sul. And this area is really important for several shorebird species with different strategies. We have some really important coastal wetland systems, such as Lagoa do Peixe National Park, Some sites are wisdom sites, some are Ramsar sites, due to the importance for the conservation of shorebirds and other coastal organisms. And specifically in these areas where I study, we have some breeding shorebirds that stays year-round here. They breed here, they spend all the year, such as colored plovers, lapwings, oyster catchers. And we also receive during our summer several Nearctic migratory species that stays here during the wintering period. And we also, from different flyways, from the mid-continental and the Atlantic flyways especially, and we also receive here during our winter, your summer, some austral migrants that breeds on the Patagonia in southern South America and the Falklands, Malvinas Islands, and they spend the non-breeding period here. So at specific points, we have species from different flyways and continents coexisting here. And these wetlands here, they are heterogeneous. The birds here use flooding grasslands, sandy beaches, as also intertidal mud flats. So since last 12 years, I think I'm interested in understand how the different species with different morphologies, different energetic demands, in living in different, sharing the area in different periods of their life cycle, how they partition this resource that they found here. So specifically, if the diets differ to reduce potential competition for food, do migratory species exhibit broader niches since they need to feed on different areas during their life cycle, some areas with some unpredictability, and if the morphology and the diet are correlated. So we capture birds here from different species to collect measures of bill, legs, tarsus, and we also collect fecal samples to study the diet, and we also use the blood samples for stable isotope analysis. And in combination with this, we produce invertebrate sample to collect potential prey and to see what the birds are potentially consuming. So with this data, we use complementary methods to understand the diet. With blood, we use the stable isotope analysis of carbon and nitrogen to build some Bayesian isotope mixing models to understand the proportion of assimilation from different sources in the blood tissues. And from different sources, I mean freshwater praise, grassland, mud flats, and sandy beaches. The isotope also allows us to understand a little bit about the isotopic niche of the birds that could be considered a proxy of the trophic niche. So we can also measure the overlap and the breadth of the birds' niches. And with feces, we use the conventional analysis of looking for undigested prey on the bird feces. In this example, like a mandible of a polychaete, we also can find elytra and etc. So what we saw here is that birds consume, it was a surprise for me, but they consume a lot of coleoptera. Many bird species rely on coleoptera as the main potential food source, but they differ in what we call a secondary prey, let's say. So birds consume coleoptera, but also different in the proportion of consumption on other prey, such as dipteras, polychaetes, crabs, and Lepidoptera. And we saw this proportion of this difference in the proportion of ingestion of prey from these different habitats. So the birds are preying in different proportion preys from the grasslands and the other areas, and they are basically grouped in two major groups of birds that rely on intertidal prey, such as clams and polychaetes, and the other birds that rely on the grassland or freshwater prey. In red, I put the birds that are Nearctic migrants, and in the blue, the species that are resident here, that breeds here and stay year-round. So With the stable isotope analysis, we found a similar pattern of different proportion of ingestion from these different habitats. And again, there are these two main groups of species relying on intertidal and on the other systems. Considering the isotopic niches of the species, we found that some species have really broader isotopic niches, especially on the carbon range, which means that they rely on prey from different environments more than in different trophic positions that could create a broader range on the nitrogen aspect of the values. And we found that this was not correlated with the migratory or non-migratory status of the species too. Some of the broadest isotopic niches were composed by Nearctic migrants, but some Nearctic migrants also exhibited some of the narrowest isotopic niches. For example, the sanderling that relies basically on the sandy beachy habitats, and the buff-breasted sandpiper that relies basically on the grassland habitats. And in general, we also found a pattern that the isotopic niche overlap was higher in comparison to the conventional trophic niche overlap, which is not a surprise because the isotopic component, they have lowest taxonomic resolution, and these methods, they inform the diet in distinct time windows too. And we know that with species analysis, we can also overestimate some hard-bodied prey in detriment to other soft-bodied prey, for example. So it's not a surprise for us. And considering the morphological similarity of the species, we could not find a correlation with the diet similarity, which means that the most similarity bills and leg lengths, for example, they were not correlated with the diet similarity. And we also know that the morphology is related with the feeding tactics and the microhabitats that birds can prey, the invertebrates, as also the prey size. So this potentially is another dimension that is important to analyze and to consider as a potential dimension that allows to reduce the potential competition for feeding during this period. And we also observed, for example, that species with the highest isotopic overlap, the ones that have this yellow symbol, they are completely different in this morphological space, let's say. So the birds are probably preying on the same sites, but as I mentioned, the differences in bill and leg lengths, they probably are related and helping to reduce this potential competition. So as a perspective, we want to include additional stable isotopes, for example, sulfur or hydrogen. This can also include another dimension and help us to understand how these birds segregate here. The metabarcoding of feces is also a potential because with this, we can see this potential differentiation in higher taxonomic resolution on the diet. And we also want to include the austral migrant species to see how the resident ones, their niches behave with the departure of the Nearctic migrants that came here to these area in highest densities, and how they are the niche behaves when these austral migrants are here too. So I put two manuscripts that you can see more details. Is a really short talk, and my email too, and I'm happy to take any questions. And thanks again for the opportunity.
Thank you so much, Fernando. And yeah, so much work to squeeze into 5 minutes, I know. So now it's time for questions for our speakers. So please do not hesitate, put your questions in the chat. You can think of questions for specific speakers or more generally to direct to all of the speakers. And you can also unmute yourself if you just want to offer a contribution or a question. So we already have one question for Gianco's talk that we can start off with from Alina about the impacts seem to be temporary, the storm impacts on food availability. and she would be interested to hear how site-specific mitigation measures could look like to help the birds affected by reduced food availability during post-storm times.
Well, thanks for that question. And I think it's really hard to try to manage a specific site when you have a hurricane because it's a very large scale disturbance. So many sites are going to be affected. But one of the things that we learned from my research is that hurricanes not only disrupt habitats, they can also improve some temporary habitats. So we had a large um, accumulation of seaweed in Nova Scotia in 2023 after Hurricane Lee. And there was a lot of food, and the birds were using that site, and that was reflected in the birds' diets. And some of these birds made it to South America. So we know that they managed to overcome whatever impact the hurricane had. I don't know if there would be any like site-specific mitigation measurements due to the like magnitude of these disturbances.
Thank you so much. And people, please don't be shy to ask questions. While we wait for someone else to submit their questions, we do only have 10 more minutes, so we can talk up to the hour mark, and then we lose our translations. So I have a general question for all the speakers about, I find it that there's so much logistics that go into doing these sort of very specific studies on like very specific communities that are often very tied to a small site. And so how do you see like the impact of your research on feeding ecology of these shorebirds at one site? How do you see that impact the literature at large or management at large in these larger questions? I don't know if anyone wanted.
I'm gonna go. I think that we can start kind of constructing and understanding what like the overall picture would be if we at least have some baseline information on like a specific site. And I sort of started with one site for my master's, and we decided to add three more, and we found that the effects are really, really different depending on site. So that can give you a better idea of how these like systems would work. And also, I want to invite all the shorebird biologists to do more research on the prey. It's annoying, but it's also fascinating, and I don't think you can do shorebird biology without understanding the energetics of it, especially with migrant shorebirds. Like it's extremely important for them. So that's my contribution to your question.
Thank you. Fernando, Lynn, did you want to add something, add a perspective? We also have a question coming in specifically for Fernando, I think. But please, either one of you, feel free to unmute yourself.
I agree with Gianco about look at the prey. Sometimes it's hard, and we need to prioritize sometimes. But I feel that there are so much things that I could understand more about the birds if we had some basic information about the prey, how they variate in these areas. Because, for example, some species, we know that the golden plovers, for example, they are basically in every site that we see here. They feed on the grasslands near the cattle, but if the area is too dry, they can move to another area. But sometimes I feel that this basic information about the invertebrate, we didn't have any publication or whatever to look at the potential species of prey that they have here. So this is something that we are still building, and but I miss these kind of things, and I think that we really have some important insights if you have more knowledge about the preys. I remember Oscar Bala in one of the talks on one meeting that said. You are used to look the shorebirds from above, but I'm used to look from below, from the prey perspective, and it's a different point of view, but you can have some important information. And I add that for example, the national park that we have here, they are now in a phase of rediscuss the management plan to implement. And again, this kind of information, it's important. We know that there's some species, for example, the buffies, they really rely on grassland prey. So what can affect this there, we still don't know. So this is something that is missing and is really important.
Yeah, absolutely. Lynn, did you want to add anything, or what are your thoughts?
Yeah, I would second what both of the previous speakers said. And sorry, I got distracted by the chat and looking at some of those questions, and I can jump in. I saw one about tourism, from Jose that was asking about the best management strategies to protect critical foraging sites while still supporting the local economy. And this was something I didn't really touch on. But for our site, we study breeding shorebirds, and the area is closed off. The actual nesting area is closed off to the public, but there's still a lot of recreational access that occurs on the oceanside area where the birds forage, pedestrians and off-road vehicle driving with over 1 million to 1.5 million people per year in the same stretch where the shorebirds are breeding. So one of the recommendations coming out of this research was to actually close off that oceanside foraging area as well to protect the shorebird. So it was something that we could share with the refuge, and independently, a separate study, they're now actually moving the whole parking lot that's supporting all the recreational access. So we'll be able to continue to study those sorts of questions in the future. But I think that is an important point, that crossover of the human disturbance with foraging.
Yeah, awesome. Thank you so much. And we have one question in the chat still by Richard Langto, about if any of the speakers have considered looking at nutritional quality of the invertebrates as an explanation of what prey are being eaten by a given species at a given time.
I'm going to talk about what we know here. I haven't personally looked at it, but these birds seem to be quite opportunistic in terms of what they're consuming, but also not necessarily would go with the most abundant prey. And that's something that we learned only recently by looking at the feces. We thought, okay, well, bivalves are really abundant here, so they might be eating bivalves. Turns out, well, with the limitations of the method, and which is you're looking at a very small time window, they're not. They would go for prey that are usually not hard-shelled and with large amounts of fat. So I think the energetics of it, but also abundance, are really important. But that will be something to consider. I don't know if Fernando or Lynn have looked into that. It's really
No, not unfortunately, no. And but I made some ash-free dry weights to look at some importance index in the masters, and the results were a bit similar with the ones based on the abundance. But I agree with this opportunistic behavior that you found, and I think Diana asked me about this in the chat too. Thanks, Diana. And yeah, one phenomenon that we found here with the sandy beach species, let's say, the species that stay most time on the sandy beach, like sanderlings, they sometimes they were opportunistically feeding a lot on the insects that came from pulses of I don't know, some breeding. Again, we don't have the invertebrate information, unfortunately, but sometimes behind the sandy beach there are some wetlands behind the dunes, and by some reason that I still don't know exactly, sometimes the beach line has a lot of dead insects, like flies and small coleopteras. And I think that a combination of the weather and the pulse of breeding, bad weather conditions for them, so they they are pushed to the ocean and they die probably, and the ocean brings them again. So we can see golden plovers and sanderlings eating a lot on this, opportunistically on this insects. Sanderlings, most of the time, they are feeding the sandy crabs, the emerita ones. Most of the eatings are these, but for some specific times of the wintering period, they forget about the crabs. They are a little bit higher on the shoreline, just on this line of dead insects, eating a lot of this.
Fernando, that's really interesting because that's something that we only recently discovered, like because with the isotopes, which is what we've been using, you would not see that they're eating that, right? You're gonna look at the plot and be like, oh, we missed a prey. We don't know what they were eating. We were looking at the feces, and flying ants are extremely important for these birds. And you have the swarming ants in the summer, and they, same as it happens in the south, they seem to fly over the ocean and then drown and then get pushed on the coast, and you'll see the birds foraging on dead ants. That it's like something that they will not be catching as they're flying, but if they're available, they'll just go for it, and they're full of fat, so it really
Yeah,
really makes sense.
nice to know that this
Yeah.
occurring in other places.
Connecting the dots here.
Yeah.
Yeah, that is really interesting.
Yes.
We are 1 minute over the time, so I just wanted to acknowledge our amazing translator, Claudia. Thank you so much. And thank you so much for all of our speakers. I appreciate everyone who has been here joining us today. And yeah, thank you, Gianco, Lynn, Fernando. Thank you so much for joining. It was
Thank you.
really
Yeah, thank you, Tara.
Wow.
We appreciate
Good to see you.
everyone, all of the participants today for supporting our initiative. And we'll announce our next coming webinar in the following few months. And feel free to check out YouTube for recent recordings of our past webinars if you missed them. This one will be posted there soon. And if you'd like to join us on Discord, we talk there and share resources, job opportunities, new papers, etc. So feel free to join us there. We really appreciate everybody coming today. The speakers were incredible. And yeah, we hope to see you next time.
Thank you, everyone.